2005 National Electrical Code, or NEC, is an important resource for electrical professionals. If you are looking to obtain a copy, there are several avenues you can pursue. One option is to purchase directly from the National Fire Protection Association, also known as the NFPA. Their website, NFPA.org, allows you to order the code online. You can also contact them by phone at 1-800-344-3555 extension 8260. Keep in mind that the NFPA experienced some issues with web orders in the past, so it might be worth following up to confirm your order status. Another approach is to check with your local wholesale electrical supply house. These distributors often carry the NEC and may offer it at a competitive price. However, availability and pricing can vary, so it is a good idea to call ahead and inquire. Holt Enterprises is another source for the NEC. They offer a spiral-bound version, which many find convenient and easy to use. You can find it on their website myholt.com. While the spiral-bound version may be more expensive than other options, the convenience may make it worthwhile. Finally, you could consider having a local print shop cut the binding off a standard copy of the NEC and replace it with a coil binding. This allows the book to lay flat, which can be helpful when working in the field. The cost of the service will vary depending on the print shop you choose. Before choosing a method of obtaining the NEC, consider the following factors. Firstly, cost. Prices can vary between different sources, so compare prices before making a decision. Secondly, availability. Ensure that the NEC is readily available from your chosen source, as you may need it quickly for projects or inspections. Thirdly, convenience. Consider how easy it will be to use the NEC in your preferred format. A spiral-bound or coil-bound version may be more convenient than a standard book. It is also important to familiarize yourself with the structure of the NEC itself. The NEC is organized into chapters, articles, and sections. Chapters cover broad topics, such as wiring and protection, wiring methods and materials, equipment for general use, special occupancies, special equipment, and special conditions, and communications systems. Articles delve into more specific subjects within each chapter. Sections provide detailed requirements for specific installations or equipment. The NEC uses a numbering system to identify each section. For example, Section 210.12 addresses arc fault circuit interrupter protection, and this is located in Article 210, which pertains to branch circuits, which is in Chapter 2, for wiring and protection. Understanding the numbering system will help you quickly locate the information you need. Within each section, the NEC uses specific terminology. It is important to understand these terms to properly interpret the code. Some common terms include shall, which indicates a mandatory requirement, shall not, which indicates a prohibited action, and permitted, which indicates an allowed action. Other key terms relate to conductor types such as THHN, THWN, and XHHW, which indicate the insulation properties and suitable applications of the wires. Understanding the definitions of these conductor types is critical for selecting the correct wiring for your installation. The NEC also includes numerous tables that provide essential information for electrical calculations and installations. Table 310.15b16, for example, lists the allowable ampacities of insulated conductors rated up to 2000 volts, based on their insulation type and ambient temperature. Using this table correctly ensures that conductors are not overloaded, which can lead to overheating and fire hazards. Table 250.122 provides minimum sizes for equipment grounding conductors, based on the rating of the overcurrent protective device in the circuit. Properly sizing grounding conductors is crucial for providing a safe path for fault current to return to the source, which helps to trip the overcurrent device and clear the fault. Table 430.250 lists the full load currents of alternating current single-phase motors. This table is used to determine the appropriate size of conductors and overcurrent protection for motor circuits. Incorrectly sizing these components can lead to motor damage or failure. The NEC also addresses specific requirements for different types of electrical equipment. For example, Article 430 covers motors and motor circuits, providing detailed requirements for motor protection, control, and wiring. Article 440 addresses air conditioning and refrigeration equipment, covering topics such as disconnects, overcurrent protection, and wiring methods. Article 517 covers healthcare facilities, outlining specific requirements for electrical systems in hospitals, clinics, and other medical settings. These requirements are designed to protect patients and staff from electrical hazards. In addition to equipment-specific requirements, the NEC also addresses wiring methods. Chapter 3 of the NEC covers various wiring methods, including rigid metal conduit, electrical metallic tubing, non-metallic conduit, and cable assemblies. Each wiring method has specific requirements for installation, support, and use. Choosing the correct wiring method for a particular application depends on factors such as the environment, the type of building construction, and the voltage and current levels. The NEC also addresses grounding and bonding requirements. Grounding is the intentional connection of electrical equipment and systems to the earth, while bonding is the connection of metallic parts to create a low impedance path for fault current. Proper grounding and bonding are essential for safety, as they help to minimize the risk of electric shock and fire. Article 250 of the NEC provides detailed requirements for grounding and bonding systems. It covers topics such as grounding electrode systems, equipment grounding conductors, and bonding of metal enclosures. The NEC also addresses overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a safe level, preventing damage to equipment and reducing the risk of fire. Article 240 of the NEC provides requirements for overcurrent protection. It covers topics such as the selection and sizing of overcurrent devices, the location of overcurrent devices, and the coordination of overcurrent devices. The NEC is not just a set of rules, it also incorporates fundamental electrical principles. Understanding these principles is essential for applying the NEC correctly. One important principle is Ohm's law, which states that voltage equals current times resistance. This law is used to calculate voltage drops, conductor sizes, and other electrical parameters. Another important principle is Kirchhoff's laws, which describe the behavior of current and voltage in electrical circuits. Kirchhoff's current law states that the sum of the currents entering a node must equal the sum of the currents leaving the node. Kirchhoff's voltage law states that the sum of the voltages around a closed loop must equal 0. These laws are used to analyze complex electrical circuits. The NEC is constantly evolving to keep pace with new technologies and changing safety needs. The NFPA updates the NEC every 3 years, and each new edition incorporates revisions and additions to reflect the latest industry practices. It is important to stay up to date with the latest edition of the NEC to ensure that your electrical installations meet the current safety standards. To effectively use the NEC, consider the following tips. Firstly, obtain a copy of the current edition of the NEC from a reputable source. Secondly, familiarize yourself with the structure and organization of the NEC. Thirdly, study the definitions of key terms and the information provided in tables. Fourthly, attend training courses and seminars to learn about the NEC and its application. Fifthly, consult with experienced electrical professionals when you have questions or need guidance. Electrical safety is paramount, and following the NEC is crucial for protecting people and property from electrical hazards. When working with electricity, always follow safe work practices, wear appropriate personal protective equipment, and energize circuits before working on them. If you are not qualified to perform electrical work, hire a licensed electrical contractor. In summary, obtaining and understanding the 2005 National Electrical Code is essential for anyone involved in electrical work. Whether you choose to purchase it from the NFPA, a local wholesaler, like Holt, or opt for coil binding, make sure to consider cost, availability, and convenience. By familiarizing yourself with the NEC structure, terminology, and tables, and by adhering to its requirements, you can ensure safe and compliant electrical installations. The NEC addresses key areas like wiring methods, grounding, overcurrent protection, and equipment-specific requirements. Remember to stay updated with the latest additions and seek guidance from experienced professionals when needed. Prioritizing electrical safety and following the NEC is paramount for protecting lives and property. This may include specific requirements for wiring in hazardous locations, detailed in Article 500 and the following articles. These articles classify hazardous locations based on the type of flammable substance present and the likelihood of its presence. Different classes and divisions require different types of equipment and wiring methods to prevent explosions and fires. For example, in a Class I, Division 1 location, where flammable gases or vapors are present continuously or frequently, explosion-proof equipment and rigid metal conduit are typically required. In a Class II, Division 1 location, where combustible dust is present continuously or frequently, dust ignition-proof equipment and dust-tight wiring methods are required. Similarly, the NEC provides specific guidance on wiring in healthcare facilities, as mentioned earlier in Article 517. These requirements are designed to minimize the risk of electrical shock to patients and staff. For example, patient care areas require redundant grounding and bonding systems to ensure that any fault current will quickly trip a circuit breaker, minimizing the voltage on exposed metal surfaces. Isolated power systems may also be required in critical care areas to prevent interruption of power to essential equipment in the event of a ground fault. The NEC also includes requirements for renewable energy systems such as solar photovoltaic or PV systems and wind power systems. These systems present unique challenges for electrical safety as they involve direct current or DC voltages that can be higher than those found in typical alternating current or AC systems. Article 690 of the NEC addresses solar PV systems, covering topics such as disconnecting means, overcurrent protection, and grounding. Article 694 covers small wind electric systems, addressing similar issues. The NEC also provides guidance on energy efficiency. Although the NEC primary focus is safety, it also recognizes the importance of energy conservation. For example, Section 210.11c4 requires that new homes have at least one 20-amp branch circuit to serve only laundry receptacles. This allows homeowners to use energy-efficient appliances without overloading the circuit. The NEC also includes requirements for lighting controls, such as occupancy sensors and dimmers, which can help to reduce energy consumption. The NEC is a complex and comprehensive document, and it can be challenging to navigate. However, there are resources available to help you understand and apply the code. The NFPA offers training courses and publications on the NEC. Many electrical contractors associations also offer training programs. Online resources, such as the Holt website, provide valuable information and support. In addition to these resources, it is also helpful to consult with experienced electrical professionals when you have questions or need guidance. They can provide practical advice based on their knowledge and experience. The NEC is not just a set of rules, it is a tool that can help you to create safe and efficient electrical installations. By understanding and applying the code correctly, you can protect people and property from electrical hazards and contribute to a more sustainable future. The NEC also addresses specific requirements for low-voltage systems, such as those used for lighting, control circuits, and communications. Low-voltage systems can pose different safety risks than high-voltage systems, such as the risk of fire due to overheating of undersized conductors. Chapter 7 of the NEC covers special conditions, including low-voltage systems. Article 725 addresses Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. These circuits are classified based on their voltage and current limitations, and each class has different requirements for wiring methods and overcurrent protection. The NEC also addresses the issue of electromagnetic interference, or EMI. EMI can disrupt the operation of sensitive electronic equipment, and it can also pose a safety hazard. The NEC includes requirements for grounding and bonding that can help to reduce EMI. Section 250.96b requires that metal raceways, cable trays, and other metal enclosures that are likely to become energized be bonded to the grounding electrode system. This provides a low impedance path for fault current, which helps to minimize EMI. The NEC also provides guidance on the selection of surge protective devices, or SPDs. SPD are designed to protect electrical equipment from voltage surges caused by lightning strikes, utility switching, and other events. Article 285 of the NEC covers SPD, addressing topics such as the location and installation of SPD, the selection of SPD based on the voltage and current levels of the circuit, and the grounding of SPD. The NEC is a living document that is constantly being updated to reflect changes in technology and industry practices. The NFPA publishes a new edition of the NEC every 3 years, and each edition includes revisions and additions to the code. It is important to stay up to date with the latest edition of the NEC to ensure that your electrical installations meet the current safety standards. The process of updating the NEC is a collaborative one that involves input from a wide range of stakeholders, including electrical contractors, engineers, manufacturers, inspectors, and consumers. The NFPA has a number of technical committees that are responsible for developing and revising the NEC. These committees hold public meetings to discuss proposed changes to the code, and they consider comments and suggestions from the public. The NEC is adopted by many states and local jurisdictions, and it is often incorporated into building codes and other regulations. When adopting the NEC, jurisdictions may make amendments to the code to reflect local conditions and needs. It is important to be aware of any local amendments to the NEC that may be in effect in your area. The NEC is not just a set of rules, it is a framework for ensuring electrical safety. By understanding and applying the code correctly, you can protect people and property from electrical hazards and contribute to a safer world.